Loud enough? I guess you turned your mic off, so I can't hear you if you answer me. Got it. Yes. Good evening, everyone. Welcome to Slooh and happy Monday night, or so it is here on the East Coast. We are just a little over a week away from the summer solstice, and so this is a fun time for us here. We have finally nice weather, the crickets are out chirping, and we are surely outside looking up at the sky. And so, what is in the sky this week is what we're going to talk about today. Many of our members have already been posting about it. So, if you've been paying attention, you might have seen some buzz around Jupiter because that is what the show tonight is about. But first, let's talk about something else. Let's talk about what you're looking at. You are looking at the new Slooh. It's live as promised, and we are here for it. It is so exciting. We appreciate all of your support and patience and enthusiasm for this. It's been 2 years in the making. This new Slooh was a total brand new web redesign, many new features, a whole education platform. And it was inspired by our project with the National Science Foundation, a grant called Curriculum Driven Gamification of Space Exploration. So we're really excited to share this with you. And obviously, if you're watching, you've already seen it. So congratulations and way to find your way to the new watch page. So, one of the new features that I mentioned that's coming with this, and you might see it if you are on the page watching the show, just scroll down a little bit, is a chat. We have a chat box for the show. So you can type. I already see people are typing in there. Hi, Carol. Slooh Engineering. Thanks. Looking forward to the show. Glad you are watching behind the scenes to make sure it all goes well. But yeah, type in the chat. You're watching with other people. So that's something that might not have really felt that way before, but we really wanted to give you that sense of community and who you're watching with. So you can talk to each other, you can talk to me. I'll be reading as best I can as I do two things at once here, and you can ask questions. So now finally, just ask questions on our page. Don't go to Facebook or Twitter, ask them right here. This is where I'm reading it live, and I'll shout you out as you talk to me. So come say hi. Some other things that have been going on around the site, you might have noticed the clubs. And so some of the clubs are set up for different topics in space, things that you want to talk about, like astroimaging. Some topics are set up by helping us out. And so a big thank you to the testers group, which we solicited anybody that wants to help find some bug reports for us and test out the site functionality. We appreciate you helping to shake this down for us. We have a new to Slooh club, which is for anybody that isn't familiar with us as an organization at all, and what does Slooh do, and how do we explore space together. And then all the old hands, all of you that have been around forever, that are, always in support of us for years now, go over to Astronomers Anonymous. That's for you. That's where you can have your centralized conversation about whatever you want to talk about, astronomy wise, space wise, astroimaging. If you want to just put it in one big chat, there you are. But otherwise, we're really trying to keep the conversations sort of in their pockets to help keep things a little bit organized. And then on top of that, there's clubs that are run by specific hosts. So you might have noticed I have a club. It's called Astronomers Wanted. And we're going to have some other special hosts coming online soon. Keep that up for the month. And we have, of course, Paul Cox. He's running Ex Machina. And we have Helen Avery, who's running Astronomy for the Soul. So if you find all of these little host clubs, this is where you'll get to talk to us directly. This is where you'll find out all about our live cast that we're doing. So right now, this is for everybody. We're talking about Jupiter tonight for everybody. But every once in a while, like particularly this Wednesday night, I'm going to come on just for my club. And so if you want to help tell me what to talk about on air, this is where you go. So if you want to interact with your host and keep up with their shows, go to the host club. So tonight we're going to be looking at a bunch of live feeds, focusing on Jupiter and its moons, which are all four of the Galilean moons are visible and looking striking. We're also going to see the Great Red Spot coming into view. We're going to talk about why we're looking at Jupiter tonight. So it's at opposition, and what does that mean? We're going to talk about Jupiter's moons in more broad detail, and I have some fun facts that I wanted to share when I was doing some research for the show. And then at the end, we have some more exciting things coming to Slooh that we'll talk about. And so remember to ask questions in the chat box. Don't be shy. So now let's take a look at our live feeds of the night. So we have 4 live feeds that we're looking at. The first one is our all sky camera. So if you're looking, you can see the all the way. Okay, so I'm like looking at it. This is my left hand. The domes are open. Our telescopes are live. The domes are open in the Canary Islands. We are on top of the mountain there, looking up at the sky. We're looking for Jupiter. You can see stars here. You can see the moon. So then if we move over to our Canary 4 solar system telescope, we should have a nice live view of Jupiter. And hopefully we will see the great red spot. It should be rotating into view. So Jupiter has an rotates about itself every 9 hours. So if you're ever trying to find the great red spot, you're going to have to either, if it's on the backside, you're going to have to wait 4.5 hours for it to come around to the front. But let's switch to the Canary 4 solar system telescope. Beautiful. Here we are. And so we are just, okay, so it's going to take your eye to focus a second, but if you're looking at Jupiter and you see the stripes all the way towards like the bottom lower third or quarter, on the left-hand side, you can see like a little red dot. That's Jupiter's great red spot. So one of the things that's going on tonight, in particular, is that Jupiter is really low on the horizon. It's only about 40 degrees altitude, and so the telescopes are doing their darndest, but it's hard when it's this close to the horizon. So we have two other feeds tonight. We have the Canary 2 wide field and ultra wide field. And in particular, the ultra wide field, Paul Cox has tuned up very nicely to show the Jupiter's moons. And so we do have a little bit of color coming in, that you might be noticing if you're looking at, this is the wide field right now. And that's just from light cloud coverage. So skies aren't perfectly clear. And so when clouds come in, they scatter some light and it can alter the color that's coming into the telescopes. But if we switch to there we go, the ultra wide field, look at that. So the big bright white dot in the center is obviously Jupiter. And then the four little white dots off to the sides are its moons. So from left to right, we're looking at Ganymede, Europa, and then on the other side is Io and Callisto. Before I get anybody in the chat telling me it's pronounced Io, it's both. So I'm going to call it Io, but hey, so we are, yeah. So if you're looking here, you're seeing the moons all splayed across from one another, but of course they rotate around Jupiter. And this is only 4 of 79 known moons around Jupiter. And so we'll talk about that a little bit more towards the end of the show. But stay tuned. We're going to take a quick 1-minute break. And you can, if you're looking at our show page, you should see a camera button where you can go to the different telescope feeds at the top of the show page. I'm just like looking at it with you. So if you're looking at the show page right above the video, you can see, just like in the old way, 1, 2, 3, 4, all the systems that are online tonight. And we have the camera button, so you can flip back and forth and you can take the images while you're watching this with me. So coming up, and just after a short break, we're going to explain what a planet being at opposition means. And also, fun fact, why Jupiter is not actually at its closest to Earth tonight, despite the idea that it should be, since it's at opposition. And then we're also going to talk about the huge number of moons on Jupiter and some fun facts about that. And then at the very end of the show, we'll talk a little bit about what's coming up for Slooh in the next couple months and why you should stick around. So I'll be right back. Welcome back. Welcome back to the new Slooh, our first show since New Slooh. So we launched just last week, and this is the first one, New Slooh. And so you might see my pretty backdrop here. Love it. We have someone anonymous on our chat saying, "Hi, Paige, I'm so into the new Slooh. It's really exciting." Totally agree. Thank you for being here with us tonight. Remember, under the show now, we have a chat box. So you're watching the show on the Slooh Watch page. scroll down and you'll see a chat box where you can talk to me and your fellow members that are watching along with you. And you can ask questions here and you can just shout out and say hi. I love it. And above the video, as always, is the different telescope feeds for the night. So you can flick through and take your images. We have the Canary All Sky, where we're watching Jupiter just above the horizon. The Canary 4 solar system has really great views of the Great Red Spot rotating into view. Perfect timing for the show tonight. And then the Canary 2 ultra wide field has the Galilean moons, very, very visible. And actually, I have quite a few friends that have been popping around on Twitter with their own pictures of Jupiter just from their backyard with like a small telescope or some binoculars and their iPhones. And you can totally go outside and look at this and see the moons of Jupiter. So I encourage you to do that. But if you're like me and it's raining where you are, then Slooh's a better choice anyway. So we're here for you. So let's talk about why we're looking at Jupiter tonight. It is at opposition. So what does that mean? Well, as it sounds, opposite. So the Earth, obviously, we're looking at this diagram here, courtesy of Hong Kong Observatory. The sun is in the center of the solar system and the Earth orbits, right? And so Jupiter is called a superior planet because it's on an orbit that's outside of Earth. So Mars, Jupiter, Saturn, Uranus, Neptune, they're all superior planets because they're further distance from the sun. They orbit from further away. So opposition is when there's the sun and the Earth, and then the planet is on the other side. Whereas conjunction is when the sun is in the middle. So opposition is when the Earth is in the middle. So if we have the sun on the one side and then the planet on the other, and conjunction would be the opposite of that. Opposition is really great because it gives a really great view of the planet. It's when it's at its brightest and it's best for viewing. So that's why we're also excited about looking at Jupiter tonight. And I hope that the feeds are telling you that, how fantastic it looks. Keep in mind, it is low on the horizon, so it's a little bit more difficult to see, but we are still getting great views of the Great Red Spot and on the moons. So, okay, one of the things I said before we took the break was that Jupiter, when it's at opposition, you think that it should be the closest point to Earth. So actually, if you're looking at this diagram right here, this seems to suggest that looking at the elliptical orbit, because the planets are all on elliptical orbits around the sun, you would think that Jupiter would be the closest when it's right on the opposite side. So Earth is right smack dab in the middle between the sun and Jupiter. But in fact, this isn't totally true. So here's some reasons why. So for starters, Earth and Jupiter both do not have circular orbits. They are elliptical. However, they're not this exaggerated. Their ellipticity is very slight, but nonetheless, that is a contributor to why the why Jupiter isn't exactly at its closest point to Earth, as you might think from looking at this diagram. Another reason is because even though they appear to lie on the same plane as they orbit the sun, and what that means is that if the sun is in the center, the planets are orbiting around on the same, like if you put a sheet of paper and like drew concentric circles, they're not exactly on the same plane. And so having a little bit of a tilt in their plane, being at little bit different distances, can account for why opposition and perigee is the word for when an object, in this case Jupiter, is at its closest point to Earth, why perigee and opposition don't line up perfectly for us. So Jupiter reaches opposition every 13-ish months, and its orbit around the sun takes almost 12 Earth years. So so as I used the word perigee to mean the closest point to Earth, there's the term perihelion, which is the closest point to the sun. So Jupiter passed its farthest point from the sun back in 2017 in February. That's called aphelion. And its closest point to the sun won't be until January of 2023. So we are now getting closer to the sun every single day. Jupiter, not Earth. Jupiter is getting closer to the sun every single day from 2017 to 2023. Earth's closest point to the sun happens every year around early January, around the start of the new year. So now we're actually getting a bit further from the sun every day. So Jupiter's getting closer. We're getting a little bit further. We both have a little bit of elliptical orbits. We don't lie exactly on the same plane. And so Jupiter's perigee is going to occur in just a day and a half. It's going to occur on the 12th. So that is when it'll be at its closest point to Earth. And another great time to image a celestial body is when it's at its closest point. You might see that we do that a lot with the moon. image it and observe it at perigee, because if you do it when it's at its closest point and its furthest point, especially with the moon, you get like a really drastic apparent size. Apparent because, of course, it doesn't actually change size. It's just what it appears that you're looking at. But for Jupiter, it doesn't actually happen that drastically because Jupiter is so much further out in the solar system than Earth. It's in an average distance of over 5 times that of the Earth. So its angular size, this apparent visual size, it doesn't really vary that much between its opposition and its conjunction. Um, so the optimal positioning too for this situation to occur when Jupiter is almost directly opposite the sun in the sky. So the sun is going to reach its greatest distance below the horizon at midnight. So the point opposite to it at midnight is when Jupiter will be the highest in the sky. So we are not at midnight right now, but you're going to want to keep watching through the night, and we should be watching Jupiter rise just a little bit as we go. So if we switch to the Canary 4 solar system, we should get really great views of, here we go, the Great Red Spot. So if you were watching in the first segment, I said it's just coming off the limb, which means the edge, and you saw this like little fuzzy red dot that was just rotating into view. And so now you can really see it. It's a much finer red dot, and it's a little bit further into view because Jupiter rotates around itself about every 9 hours. And so I mean, I won't be on that long, but you could actually watch the whole Great Red Spot orbit in one night. And the other reason that the Great Red Spot looks a little bit better now than it did just a few minutes ago when it was on the side is because of this limb darkening effect. So when a feature is on the edge of a celestial body, a gaseous body like Jupiter is, we have some effects from the light coming from the edge. And so you're better off viewing the feature when it comes into view. So keep watching this Great Red Spot. And if you watch it over the course of a few hours and take a bunch of images, and you can put them together into a time lapse and share it with us, we would love to see that. So if you have any questions, feel free to post them in the chat. I am monitoring it. And when we are gonna take another quick little break, but when we come back, we're gonna talk about Jupiter's moons, and how many there are and how recently we've discovered them or not. And I have some fun facts about the moon that I wanted to share. We're also going to talk about what to look forward to in the next coming month at Slooh, because new Slooh wasn't the only thing that's happening, and we're excited to share the rest with you. And so, if I mean, the breaks are short, so I wouldn't really leave the page that you're on, but after the show, feel free to poke around. We talked a little bit earlier about all the clubs that we have and how the hosts have different clubs, and that's where you can follow things like my live cast series and that of Paul Cox's and Helen Avery's and some other fun special hosts that will be coming online this month. And we have different clubs for your different personalities and your different interests and your different support of Slooh. If you are brand new, we're here to help you. And if you've been here forever and you want to just talk about that, we have a club for you too. So stay tuned. We will be right back after another short break. Hi, welcome back. Hope you've been enjoying watching with the new Slooh tonight. So we are watching Jupiter at opposition, and we were just talking about what opposition means and why that doesn't mean it's the closest point to Earth. So just a brief recap is that Jupiter being in opposition means that it's on the opposite side of our night sky as the sun. So the sun's on one side and Jupiter's all the way on the complete opposite side, which makes for really great viewing. Unfortunately, it is at a low altitude. It's not far above the horizon, so that makes it a little bit difficult for viewing. So we're kind of playing like a catch-22 here. Um, but it's also coming to its closest point to Earth, and that is happening on the 12th in just about 1.5 days. So that didn't occur on the same night as opposition because, as I was trying to explain earlier, the way the elliptical orbits happen, the way we're not lying in exactly the same plane, it just doesn't line up that perfectly, but it's pretty darn close, right? It's just not exactly perfect. But it's also a great time to observe Jupiter for the same reason, because Jupiter is the closest point to Earth. So now we're going to talk about Jupiter's moons. So we can, yes, thank you for that graphic, studio. So I really loved this, and this is what I've been excited to talk about tonight because it was something that I actually just recently learned about too. And so Jupiter has 79 moons, and that was recent. So back in March of 2017, they had discovered 10 more moons around Jupiter. And so before that, it was in the 60s, and that was the last figure that I remembered. I didn't know about this 10 new moon update. So 10 new moons just a couple years ago. And the first thing that you might be wondering is like, why so recent? Like, Jupiter's in our backyard. How come it took so long? Are there more moons? And there totally could be more moons. And the thing here is that these moons can be small and they can be really hard to see. And unlike our moon in our night sky, which we see beautifully every night, obviously our vantage point at Jupiter is not the same. So it can be really hard to find these small bodies that don't make their own light. They only reflect light coming off of the sun and their host planet, right? They're not creating their own light because they're rocky bodies. So they can really get away with hiding for a very long time, and they can be very, very small. Jupiter's moons range anywhere from about 1/3 Earth distance to about 60 Earth distances. So the Jupiter is Jupiter is a gaseous body, but like don't let that fool you, because we believe that it might have a rocky core, but aside from that, it is so huge. It's so massive, and it's so therefore its gravity is so strong that it can keep objects, moons, in its orbit up to over 18 million miles away. Our moon, our Earth moon, is just 240,000 miles away. But Jupiter could have moons all the way out to 18.5 million miles away. So that's why these are so hard to see. If they're out that far, we're not going to get their light. They're barely reflecting anything off of their parent planet and our sun. And they're also likely so small. But another thing, if you've been staring at this diagram, which I will get to in just a second. So if you're, we'll go back to it in a minute. We don't have to do it right now because I do want to talk about the diagram. But on the Canary 2 ultra wide field, we are looking at Jupiter with its 4 Galilean moons. And so on this diagram, you can see in purple the Galilean moon orbits. Then a little bit further out is called the prograde group. Prograde means that the orbit of the moon is in the same direction that the planet is spinning. So Jupiter spins one way and the planets orbit in that same direction. They're called prograde. Then further out, we have the retrograde group. So that means, as you might guess, that Jupiter's orbiting one way and the planets or the moons are orbiting the other way. So opposite. Okay, and that's fine. And you can see from this diagram that they're super far away. And actually, the ones in bold here are the recent discoveries. But you can see that these orbit groups are super far away from one another, so no big deal. However, if you see that lime green orbit there, I'm not positive I'm pronouncing this correctly. I'm just sounding it out. Valitudo is a new moon that was discovered in March 2017, along with 9 others. But this one, it's out in the retrograde group. It's super far away, but it has a prograde orbit. So all these moons are coming this way, and this moon is just like, sayonara, I'm going that way. What's crazy about that is talk about a collision course. And so this is something that, we always talk about collisions on Earth because we're so curious, like, when are we going to get hit like the dinosaurs? But this is huge. So watching this moon, it's going to crash into so many things potentially. And what's really interesting is when you think about the potential formation for it, it's possible that this Valetudo moon was much larger a long time ago, but has been since broken down because it keeps crashing into other things. And that would just create more moons because they keep breaking apart, but they're going to stay within the gravitational pull of Jupiter as long as they're within that 18.5 million miles. So I just thought I was so excited to share that. I thought that fact was super fun when I heard about that. Um, so we can go back to the Canary 2 ultra wide field where we are looking at Jupiter and its four Galilean moons. So these Galilean moons are named such because Galileo Galilei discovered them with his first ever backyard telescope. Um, and they are much easier to see. As I was saying earlier, you can go out in your backyard and look at the moons probably through binoculars or a small telescope if you have clear skies as well. We're looking from left to right. We're looking at Ganymede, Europa, Io, and Callisto. So these moons, if you image Jupiter over the course of several nights, you'll be able to actually watch the moons orbit Jupiter. And so you can create a really cool time lapse if you take several images as you watch them orbit. And then let's take a break from moons and go right back to the Canary 4 because I want to see where the Great Red Spot is. There you go. Great red spot, bottom left corner. So you can watch that over the course of the night too. So watch the great red spot, watch the moons, take several images as they change, and then just put them in a GIF maker and you can create your own time lapse. And then you should share that with us so that we can see it. So we've been watching Jupiter at opposition tonight. And in just a little under 2 days, we're going to have Jupiter at perigee, which is its closest point to Earth. So stay tuned for that too. Coming up, we have some really exciting things. July 2nd is the South American total solar eclipse. We will be live, of course, all day watching this. So excited. The Transcontinental total solar eclipse was in August 2017. And so that's been a while, but I feel like people are still talking about it. And like you'll go somewhere and well, first of all, as soon as I tell somebody what I do, they're like, "Oh my God, the solar eclipse! I know." But even in the science community, we're still talking about that solar eclipse. So I'm really excited to see this one. And of course, I don't live in South America, so I couldn't see it without coming on live here. So if you can't see it either, you should join me here. We will be watching it live. We're gonna have a huge kickoff party to celebrate the total solar eclipse, the new Slooh. We want you to be here for it. Participate with us in the chat boxes under the show. And yeah, just stay tuned. We're starting a couple of us are starting our live cast host series this week. So you can look for me Wednesday night. I will be live at 7 p.m. Eastern time, Eastern Daylight Time. I'll post all about it in my club, but you can come listen to me talk while we look through some telescope feeds. So we'll be starting several of those different series coming up too. And then, of course, culminating in the big total solar eclipse, July 2nd, new Slooh celebration. Join us for it and keep your eye on Jupiter for the week. I will see you all next time. Thanks for coming.